temperature of the T3 sensor, which is the condenser coil sensor, and the value range of the temperature change, then the compressor takes that into account and does a total cumulative runtime. And that's how it determines how long the defrost is going to take and how long it, or when it goes into defrost. During the defrost mode, the compressor keeps running. However, the indoor and outdoor fan motors stop. And most of your indoor units that have a display on them are going to read DF for defrost. This has 4 conditions on it to when it'll go into defrost. There's now 5. When the compressor reaches a total cumulative runtime of 129 or 120 minutes, that's when it will go into defrost, as long as it the T3 sensor is reading the correct temperatures. To exit defrost, any of the following conditions will terminate defrost and return the unit to normal. Would be the T3 temperature sensor the T3 temperature sensor rises above 59 degrees or remains above 46 degrees for more than 80 seconds. This will bring it out of defrost. The unit also stays into defrost for a total of 10 minutes. Condition 4 in this case is the cumulative runtime. However, I'm going to go over some of the most common error codes we have and some of the ways to troubleshoot them. E1, E2, mostly it's E1 is our most common error code. This includes for troubleshooting the wiring, condensate pumps, voltage interference, sometimes control boards. You need to check your compatibility charts, make sure your indoor outdoor units are compatible. Multi-zone systems, you need to make sure you have the correct A going to A, B going to B, C going to C, make sure that's all correct. Then when you're checking for communication, you want to check DC voltage between L2 and S. And now between L2 and S, the voltage should vary between 15 to 60 volts DC. And it's a good idea to check this at both the indoor and the outdoor units. Some of the others I mentioned are condensate pump. If you follow the installation manual in the condensate that comes with the condensate pumps, it's going to have you wired into the S wire, the signal wire. That's not how Carrier Bryant once there's wired in at. If you do that, sooner or later, if not immediately, you will get a fault code, an error code. So always break L1, which is not used for any communication. If you need us to send you this, it can easily be sent to you. Just email it to you or text it to you through our text line. Do not ever splice wires. Never use solid core wire. Always use shielded stranded 14 gauge unless the installation manual calls out for a larger wire to be used. And that would only happen if it's an extremely long run. So always refer to your installation manuals when you're questioning that. For communication testing, this is what's called the transformer effect. Shut the power down. You remove your S wire from the indoor and the outdoor unit or units. You want to set your voltmeter to AC, and you want to test your S wire to ground. Obviously, with no power, you should get 0. If you don't, then you have something's touching that shouldn't be touching. Power the system up. Check it again. You want to check between DS wire and ground. And most of the time we want 0 volts here. The units will usually handle anything under 24 volts of power. I like to keep it around 20 volts. That way we don't have to worry about this problem, about the transformer effect. If you think you have this problem, you can run a temporary wire in between the indoor and outdoor unit, just connect it to L1, L2, S, throw it out the window and connect it outdoors and see if that solves your problem. So this is straight out of the installation manual. Always use stranded shielded 14-3 gauge wire. This also includes for the temporary wiring that I just mentioned about, when you just wire between point A and point B and throwing it out the window. Now on the multi-zone systems, usually it's the MGRs, it has a automatic wiring and piping correction. It is not recommended that you do this. Go ahead and unhook the wires or unhook the piping and put them in the correct spot. This will avoid any future problems you could have if you had to change out a board or a head unit or the outdoor unit or anything like that. And the reason that we don't want you to do that is because you hit that button to solve your issue. But if you had to change a board, then all of a sudden you're going to have this issue and you're going to be, questioning what's going on. Obviously you want your refrigerant lines go from A to A and B to B. And you also, units A to B. And now we're going to check out which board is bad. Now there's a couple ways to check this. This is the first way I like to check it, and then I'll go into the second way later. So with the S wire connected indoors and the S wire disconnected from the outdoors, you apply power, you position your red lead and your black. The positioning of your red lead and black leads is very crucial. You want to put your L2 for your red lead and the S terminal for the black lead on the outdoor unit. And you're going to be reading DC volts. You want to see negative DC volts with a little bit of pulsating. If you do not see any negative DC volts with pulsating at the S terminal, then more than likely your outdoor board is bad. So then you're going to switch over and you're going to leave your red lead on L2. You're going to move your black lead to the S wire that comes from the indoor unit. And you're going to check for pulsating DC volts there. If you do not see any positive DC volts pulsating from the indoor unit, then that board is bad. Now, obviously, we don't want to do that 100% because that way is wrong. We're going to check them other ways. And I'll get to that in a little bit further in here. So you got the P0, P4, and P6 codes also. This is for, outdoor board. The IPM, you want to check continuity on it. If you got one of these with the P in them, you obviously want to go outside because that's usually where the P codes originate. You want to check your compressor. Make sure compressor ohms out correctly. Unplug the compressor. Does the code go away or does it change? Is your compressor noisy? You want to check and make sure your compressor didn't get hot. Melted the stickers, burned them a little bit, maybe curled them, discolored them. You can check the interior of the compressor blanket, see if it's discolored. That's not always 100% accurate because sometimes just age discolors them too. You want to check your refrigerant level for these error codes. And there's only one sure way to verify you have the correct refrigerant level, and that is to recover your refrigerant, weigh it out as you're recovering it, compare it to the data plate or any extra line length you have to add for it. And obviously, if you're low, then you have a refrigerant leak someplace and need to track that down. So now we're going to get into checking the IPM board for continuity, and you can do this. This is the inverter board, the one that has the compressor hooked to it. The indoor board also has this, but it's hooked up with the indoor fan. It can be checked this way. It's just not as accurate or as easy. So you're going to take your, you're going to look for a P or the N terminal on the capacitor. Now we're going to be checking for resistance. There's no real set resistance. We're just looking for close resistance. You want the same amount. So you're going to check between P and UVW. You want to make certain you got a good connection from your meter. All these IPM boards have a positive and negative side, and it just depends where your meter leads land. It's much more accurate if you're on the positive side than what it is on the negative side. So if you're reading this and you get negative, you're not getting what you think you should get, go ahead and switch your leads around and move your red lead to a different part of that board. The best way to do it is to find a capacitor, and I'll get to that shortly. You do want to make sure that you disconnect power and leave it off for 10 minutes. Nobody likes to get shocked. Sometimes you may need to scrape a little bit here on the solder. There's a clear coat over that, and you just want to scrape it sometimes just to be certain you have a good connection. Don't get carried away. We don't want to damage the board if it's not damaged. So this is usually the best place to find where the positive and negative side of the board. And this is the back side of the board where a capacitor is. And usually you have an outline of capacitor, and one side's the positive and the other side's the negative. So usually what I tell you guys when you call in is you look for this circle, you find the little half court basketball thing in there, and you find the rectangle that goes with it. And this whole thing over here is the positive side of the board. Now that also will stretch over into, anything. You can scrape off anywhere you wanted to check that positive side. Now, some of these boards, it's marked where the positive and negative side are, whether you see the plus sign or a negative sign or a P and N, or, the POS or a negative sign or NEG. It's just not always marked, but this is the best way to test your board. And we're going to test out a compressor. Now, compressor ohm readings vary depending on the compressor and also the temperature outdoors. Well, maybe not outdoors, but usually that's where your unit's at, is outdoors. And we're going to check these out like a 3-phase compressor. So we're looking for resistance all pretty much within 10%. We don't want to go over 10%. Now, if you want to check these through the wires, that's fine. Just take that into consideration. Always check for ground. And we're going to check our reactor. System's still off. So we're going to pull the wires off. We're going to check resistance. And we're looking for 1 ohm of resistance or less. If you have anything 1 ohm or higher, you need to replace that reactor. And don't forget to check it to ground. Always check everything to ground just to be certain. So now we're talking about the fan motors, and these ohm out just like the compressor. They're 3-phase. They're going to check out like 3-phase DC motors. Once again, you look this stuff up in your service manual, and it'll walk you through it step by step. And temperature does have an effect on the resistance readings. If you have any resistance to ground, replace the motor. You obviously want to see if the motor spins freely, if it's, broken. I've seen broken blades and things like that. They're just plastic. If a chunk of ice hits them or something, they could easily break. Checking your EEVs. You want to look for, you want to pull the plug off the board and you want to check and see what you have. You want to check between, this is also in your service manual, and you want to have around 46, usually around 40 ohm, or not 40, my apologies. Around 50 ohms is good, but you want to check between brown and yellow, you have 46, brown and blue, 46, red and orange, 46, red and white, 46. But if you check between, in this particular case, between orange and white, you will probably wind up getting 100 ohms. That's nothing to freak out about or nothing. You're just reading the full extent of that winding. And once again, please always check it to ground. If you have a ground, sometimes it can read as you have 0 volts DC. And here's the 5-wire one. So it's the same thing. Just check them out. Make sure we got that good. You also want to be certain that they're seated good on top of the valve. They should spin, but if you can grab a hold of it and lift up, then we know it's loose. Push it back on there till it clicks. And now we're looking at the 4-way valve or the reversing valve. These are high voltage. So when this unit's operating and heating, we have 230 volts AC going to them, or 115 volts, depending on your incoming voltage. If you're not reading the voltage and it's supposed to be, or it's not within that range, then chances are your PCB board needs to be replaced. Now, if you want to ohm it out, you can do that. You want to check for your resistance value is 1.8 to 2.5 resistance on the coil. Obviously, anything to ground, you want to replace it. So just to be certain, this thing is powered up in the heating and there's no power going to it in the cooling. So E3 F5 code. Some people also get the 88 error code on this. Now, I had one the other day where everything was running perfectly and he still had an 88 code. We believe it was the display board was bad and it just had everything lit up. He had replaced the indoor board earlier. So just to be certain, there's sometimes if you get that 88 code, it could be just the display, just everything lit up on it. So you also want to make certain your blower wheel spins freely. You want to check for resistance. And it's checked for resistance just the same way as we did the outdoor fan, the compressor. You want to refer to your service manual for the resistances. And once again, anything to ground, you want to replace that board. Not that board, that motor. So I just thought I'd put this up there and kind of a classic of, what not to do. Just knock a hole through there. Now, granted, it's cooling or heating 2 rooms. Just not, the way most people would install it. So on your display boards, and I just mentioned the 88 code, as you can see here on this picture, if the display is malfunctioning or something and it's not an 88 code, it just lights everything up, and like most digital displays, it lights them all up and looks like an 88. So on the display board, you should be receiving 5 volts DC from the main board. And you can check that at the gray and black wire, and then the red and white wire, and then the red and black wire. one or more of these values should be around 5 volts DC. One might be ranging and another might be around 3 volts. That's nothing really to panic about. We are getting voltage there and it's talking. You can try this in the manual mode and see how the unit reacts. You can also shut the blower off and on. You want to make sure the remote is pointed at the IR receiver. And now we're looking at the FC code. This is a position on most GRE units. It is the louver positioning, meaning it just, the louver isn't closed all the way. Something's jamming it. Maybe the motor's not turning. The gears are stripped. Just shut the unit off, reset the louver by closing it all the way, and turn it back on. P5, old models, mode conflict. Sometimes we also get the double dashes when it comes to this. You cannot, like all heat pumps, you can't run it in heat and cool at the same time. So in this case, if we have multiple indoor units, and you're running it, one in heat and one in cool, you will get this. Sometimes you have to cycle the power in order to get it to reset. So if you have a leak that you're low on refrigerant and you can't find this leak, it's a good bet that it's more than likely it's your flare nuts. That's why it's always a good idea to torque them to the correct settings. Torque wrench with a backup wrench. You can put some oil on there and make sure you're not spinning the pipes. But just what it does is it expands and it contracts just enough for you to lose a little bit of refrigerant. So that's always something to look for. You can look around there, obviously, for oil and stuff like that. But if you find that you're low on refrigerant and you can't find the leak, go get yourself your torque wrench and reset those flares. Now you want to use a dedicated flaring tool for R410A. And that's because the R410A makes a larger lip on the flaring. You want to be certain you clean everything out, have a good one, and nice and smooth. You can move your finger around there and not going to slice your finger open or something. A couple pictures of bad ones. You obviously want to have a good tubing cutter. So here's the difference between the standard flares like they used in R22 or even the old gas lines. I'm sure there's still some of those out there. So you can see a distinct difference between the R22 and the 410A flare. It's almost double the size. And this is done so it'll handle higher pressures. So I like to do this just to kind of put this in there, and it looks like they got it mounted pretty good. I think they're probably going to have an issue with oil return. And we got the P6 error code, low protection switch. Once again, this is one of those P error codes. So you want to just go on outside. If you're inside and take a look out there, you want to be certain you have the proper refrigerant charge. We discussed the best way to do that. It's not always a good idea to first attach your gauges. Gauges will tell you yes or no, you have refrigerant in the system. They're not going to tell you the correct pressures to what you're running at because these are variable speed systems. So they run at different speeds. The best way, if you're going to check and see without pulling out the refrigerant, is what your temperature drop is across your coil. So on the P6, you also want to check and be certain your low pressure switch didn't get, hang on here. We got I got a question here. Are the new ductless systems going to be for R32 or? As far as I know, there's still going to be flare fittings for these new refrigerants. I haven't heard anything to the contrary. That's for clay. I can look into that more, and if I see that it's different, I can get with you and let you know what that is. So pressurizing with nitrogen, Carrier requires 500 PSI dry nitrogen. You may, in some of the manuals, it says 150, pressure tested up, to 500 pounds of pressure. It's a good idea if you can let it set for 24 hours to see, let it set for 24 hours. I do understand we're all on a time crunch. So at least ways let it sit for 15 minutes, 30 minutes, something like that to just see if it moves. But best case scenario, best practice is to let it go for full 24 hours. So this is something that this comes from up at Carrier. They're requiring either videos or pictures of all leaks on any coil. And that used to be just with ductless, but I'm going to go ahead and say that's not with just ductless anymore. As many of you know, that's also with all evaporator coils and condenser coils. They want either a nice video like this or soap bubbles. So we can't do, it's very difficult to get a unit replaced without a picture or leaks or leak detector like this. So if the coil is leaking, do this, get a picture, get a leak, because sure enough, you're going to go to the counter, you're going to order it. They're going to tell you it's back ordered for 2 months. You're going to want to get in contact with us and see what we can do about it. And one of the first questions we're going to ask is, do you have a picture or a video? Without those, it's going to be very difficult to get it done. So this is another example of how not to install. These units can't breathe. None of them can. They look like they're a pretty convenient height on these over here to work on, but they're not going to be able to breathe. So airflow is going to be an issue. You're going to keep having multiple fault codes. Surge protection. Some places have high voltage problems due to brownouts, fluctuating voltages, frequent power outages. We do recommend that you install this, surge protector. This does not protect against low voltage. So if you're dropping voltage, not dropping out of voltage, just your voltage is dropping down to, I believe it's 197, 193 volts. This is not going to pick that up. But these ductless units are very sensitive to voltage. So here we're going to go over the sensors. If you have a faulty sensor, 9 times out of 10, you're going to get a fault code. So T1 sensor, where's that at? T1 sensor's room temperature sensor. T4 is your ambient sensor. T3 is your condenser coil, which is usually pretty hard to see. T5 is a compressor discharge sensor. And over here we have your evaporator sensor, which is the T2 sensor. And we can check this against the chart, and all these charts are in the service manuals. Let's see here, we got another question. They only accept video of bubbles, they don't have or have not been accepted videos with electronic leak detection. They only accept video bubbles. It depends on the situation, Eric. I mean, a lot of times you're not going to be able to get a video of the bubbles. We've been able to push some of them through with the electronic leak detectors like that. A lot of times it's a good idea to start further away and then kind of come in so they can actually see what you're doing. Now, if it's in the coil pack, obviously you're not going to be able to see the bubbles most of the time. But if it's on the bins or the joints or stuff like that, you'll be able to see it. So performance issues, but not getting an active error code. Refrigerant charge is the main one you want to check. And we discussed how to get that, pull your refrigerant out, check it against your data plate to add in for any extra line set. If it's low, you have a leak. It could be in your coil, could be just a line rubbing. Somebody could have drove a screw through the line set. You also want to verify your flare nut works. Also, if you have overshooting or undershooting by a couple degrees, sometimes we can utilize the temperature compensation and take that out of this scenario, and it'll fix it. We strongly recommend you do a load calculation if you're getting a lot of overshooting and undershooting. It is possible for a thermistor or internal device to be the issue and there not be any active errors. That's why sometimes we want to check against the chart. So next we're going to hit geothermal. We'll go over that really quick. If you need a more in-depth class or anything on geo, you'll have to let us know. Most common error codes, purging ground loops, different types of loops. So the main difference between residential geothermal and your traditional air source is the fact that the geos, where they get their name, is they use the energy from outdoors. You remove and you extract, and that's the same as remove. Sorry about that. You put heat into the ground and you remove heat out of it. Usually the ground stays around 45 to 60 degrees. The geotechnology has is available from the heat in the cold weather months and puts heat back into the ground, during the warm weather months. So after you're running your geo unit for a couple years, it really runs more efficient than what it did for the first time. So there's several different types of loops: closed loop, open loop. Open loop systems require a inlet filter, so you don't get all sorts of junk and garbage inside your system, kills your pumps, things like that. Pressurized loops, you need to check your pressurization. You want to get the bubbles out of there. And on these pipes, they do expand and contract just like the copper lines. So sometimes on a pressurized loop, you could have an issue where it's kind of pulled the pipes inwards. This doesn't happen too often, but it does happen. That's just need to pressurize your loop or purge it. So flushing and purging is required on all closed loop systems. And you want to do this with three-way valves are needed. at your pump motors or flow center. And you want to do this with a minimum flushing velocity of 2 feet per second. So basically, bigger the motor you have, the faster you can push the water. And you want to get the micro bubbles out of there so you don't have that. Those micro bubbles will eventually become one bubble or several larger bubbles, and they will cause more issues. You want to put an antifreeze in there. Most anybody anymore uses glycol, propylene glycol. It's just the food grade inside city limits and everything. They want you to use that. Used methanol and ethanol before. Troubleshooting. We're going to go over a few flash codes here. Flash codes. The amber light codes will be in a series, just like on the others, where it's short and long flashes. On the status light, short flash is 0.25 seconds, and the longer flash is 1 second. So it's just like on the our regular systems. So here's several active codes: high pressure, low pressure switches, internal board failure, brownouts, compressor thermal lockout, low pressure, high pressure, condensate overflow, freeze protection. We also have comfort alert systems on a lot of our geos. For the comfort alert diagnostic, it's monitoring the device. Sometimes it'll give you a shutdown. It'll shut down the compressor depending on how they're installed and which units. Most of these are on the GT series. When you have an abnormal condition, the comfort alert module, it'll display the alert and the trip LED. The yellow is the alert, and it'll flash a certain number of times. Like any error code, it's giving you the general vicinity. You want to troubleshoot a little bit. Don't just assume that the comfort alert knows exactly what it's doing. So the comfort alert, every time it powers up, the last alert will flash that occurred prior to the shutdown. Excuse me. Now we're going to get into the Smart Start Assist. This is on the GT series. Smart Start Assist is designed to reduce the inrush voltage during single phase scroll startup. Kit contains 2 parts, the main part and the mounting plate. Kit's installed on top of the unit's electrical box. The SSA reduces compressor starting during currents and limits the peak to kind of, keep the lights from dimming and stuff like that. They have a dedicated algorithm that's built in. We have no control over that. The SSAs, they will lock out. They'll incorporate their own 5-minute time delay. All this can also be found inside the service manuals. When you want to de-energizing the SSA is the only way to really override its built-in time delay. The SSA can be removed from the system. And you will have to rewire the compressor and the capacitor. Also, the SSAs are no longer available. So once you remove one and you still having issues, you can put in a hard start kit. So over here on the left-hand side is wiring schematic, a cutaway of one with the SSA wired in. And then on the right-hand side, you have removal of the SSA. And, it's just like your standard compressor, wiring the capacitor, run start, common. And we can send this to you if you need us to. So there's a few questions. What's the best way? What's the best way to connect a drain fitting to either PVC or tubing? It is metric on the high wall heads. So the tubing would be the best way to go to get it out to where you can get to it. You know, if you're going out through the outside wall, you know, that's kind of, you know, whatever you want to deal with. Is it, do you want to deal with the PVC or the tubing? It's not really it's more of a preference, not so much a best way. It's just a preference. I personally like the PVC because you didn't have to worry about getting tightened down too far, you know, kinking it off. That's just my personal preference. Okay, so that ends my part of it. We're going to turn it over here to Ben in just a moment. At the end of this, there will be a test, QR codes and everything like that. Is there a good adapter? The metric connection doesn't make a great seal. We don't have a good an adapter for that. You would might want to check at a hardware store and see if they have something that would go from one to the other. But CPD doesn't have a connector that I'm aware of, unless Rob or Ben knows of one.
I don't see that question. What is the question?
It's in the Q&A. Question from Scott Long.
Oh, I'm in the chat. Okay, hold on. I'm sorry.
Down there at the bottom.
Yeah. Off of what connection are we talking about?
He's talking off the high wall units.
For the line sets or to get onto the server?
For the drain line.
No, I do not know of any.
Yeah, yeah, Scott. See, we don't usually deal with that because that's outside the unit. So that would be something you would have to get a hold of I'd just go to the hardware store and see what you can find, and you find one. Let's see.
Hey, Scott, we can try to get a hold of the factory tomorrow, put that into them, and we get a response. We can go ahead and follow you up with a telephone call or an email.
I didn't know I was breaking up. The SSA casts are already come installed on the unit. You can't buy them anymore. They're obsolete. So you could put a hard start kit in place of one. You'd have to remove it totally and rewire the system, which is what that diagram was. That diagram right there. Right here, we have the SSA that's wired in from the factory. And because they're no longer available, this is how you would remove it, and this is how you would wire in your compressor. I know it's kind of sloppy, but you know, I got the job done. All right, I'm going to turn things over to Ben, and he's going to go over furnaces. So go take a small 10-minute break, and we'll be back about 4 o'clock straight up.
Craig, do you see my screen in presentation mode or not?
No, I haven't stopped sharing mine. Okay, I do not see see yours at all, man.
What about now?
Yes.
In
Looks
presentation
good.
mode?
It's in,
Got it.
yep. It's
Yep,
in the
I
right
see
mode.
it. You're good to go whenever they get back.
Got it. All right, sounds good. All right, guys. Looks like Matt wanted to know how long we were on. We're on till 6. Frank, do you have to pass the test to get your fat and Nate credit? Yes, you do. With that being said, I'm Ben Point. I'm one of the cams out of Omaha. I'm going to do some communication topics right off the bat. Then we're going to hit into furnaces, some diagnostic codes, and some airflow. So hopefully everybody's back. 4 o'clock on the dot. Communication diagnostics. This is a big one. We get a ton of phone calls on having indoor outdoor communication errors, equipment not hitting, whatever be the case. We're gonna go over that. So where does communication start? It originates out of your IDU, your furnace board, indoor unit board. Then it hits off to your AC heat pump, whatever you got, and then also hits into your UI. Now, with that being said, a lot of guys don't know how to check this. I'm going to kick over to the next screen real quick. I'm going to leave this screen up here for about 40, 50 seconds for everybody to take a picture of if you want it. This is very, very good to have if it's been a while since you've had communication issues or first time. This is going to tell you your voltages, what you should have, what you shouldn't have when you're unconnected and connected to the system. And then we'll touch on these numbers here in a minute when we'll kick to the next slide. Like I said, I'm just going to leave this up for about a minute so everybody get a picture of it. And then we'll go from there. Keep in mind when you're looking at these numbers, if you're dealing anything with A or B, you're in DC voltage. The only time you go to AC voltage is if you're dealing with C to D direct, but everything else is in DC voltage. Go over to the next slide here, how to test. So first thing you want to do anytime you're getting these errors, first, I should put it on here, but shut your system completely down, do a reboot. You can even do a reinstall on your thermostat. About 80% of the time that fixes your problem. If that's done, your problem's not repaired. We're moving forward with these following steps. On your furnace board, take your ABCD plug off of your furnace board, power applied to your system, check DC voltage between terminals A and B coming straight off the board, right on your pins. If we refer back to that previous screen, should have roughly, this is saying 3, we say 2.5 to 4 volts DC between A and B pins coming off the board. So we'll use 3.5 for just a roundabout number in this conversation. So you got 3.5 coming off your board with your plug disconnected. You plug back in, let's back up here one screen again, plug back into your board. Top half of this chart, you're disconnected, bottom half, you're connected. You plug back in, now you should be going 2.5 to 4 pulsating voltage between A and B with it plugged back into your board. Then we're gonna move outside. We'll hypothetically think that we're working on an outdoor unit, unable to be found. So we're gonna go outside. We're gonna do exactly what we just did inside. We're gonna pull our plug off our outdoor unit. We're going to now check our wires coming from inside. So theoretically, we had 3.5. We go outside, we should be in that 3.5 range. You might lose a little bit here or there, but not dramatic decreases. Say you get outside and you have 0.1 or 0.2. Well, we obviously have a problem. We just lost all of our power. With that being said, you could have a bad wire, but you could also have a bad joint if you're jointed. Like Craig spoke on his spiel, we want these communication wires to be continuous, no splices in them whatsoever at all costs. If we have to have splices, this stuff is so critical, it's ridiculous. Make sure your splices are tight. Do not spin your wires together prior to putting your wire nut on. Let your wire nut do that for you. Make sure you have good wire nuts. Another thing to check, make sure, especially if you're going back on a follow-up of another tech that couldn't figure this out, make sure that those wires are still A to A, B to B. I get it a lot that guys will be fighting this, and I'm like, check your wires, and they've been crisscrossed A to B and B to A. Make sure A is to A, B is to B. If all's good there, your joints are good, you're not crossed anything, and you go outside and you still have 0.02, time to pull a new wire. Now, say we have our 3.5 outside on our wires. We're gonna now go to the control board off the outdoor unit. Power applied. You should be getting 2.5 to 4 off of your control board. If you're not, if your transformers, everything's good outside and you're not getting your outdoor power coming off your outdoor unit, you have a bad board, it needs to be replaced. Chris Lindsay. Oh, it looks like Craig answered you already. It depends on your model of your unit. So I'll let Craig follow up on your question with you, Chris. But with that being said, now we plug back in. We should be getting 2.5 to 4 volts fluctuating DC voltage plugged back into our unit. Now you go up to your UI, you want your 3.5 volts up at your UNI. It's, I mean, 3.5 is the number we're using. It's not always going to be that, but you want that up at your UI. If you're not getting, if you're getting it up to your UI and you're still having problems, start looking at your UI as being an issue. This is, it seems very, very threatening and difficult to troubleshoot a communication circuit. It's actually very easy once you do it a couple times and you understand what voltage you should have where and when. If you get on one and you're having problems, can't figure it out, give us a shout. If we have the time, we'll sit and walk through it with you and test it out with you. Very, very seldomly is it due to a CD terminal issue. It's usually in your A and B is where your communication is. C and D is your power back. Here we are. Wires test low, replace wiring or check for loose joint crossed wires. If board test low, replace the board. It always make sure to double check your wires. That's probably 75% of the time is going to be your problem is a wiring issue, not a mechanical equipment issue. So on the gas furnaces, we're going to hit over pretty much 59900 series. It's prior review for a lot as we haven't switched up a series in a hot minute. But just go over some of the basics, give a kind of a review. Nomenclatures. When you're calling us, sending us an email, a text message, a request form, anything, please include a full model number and serial number. This shows why. I mean, if you just call and say, hey, I got a 59 TPA. All right, well, we know what series you're in. Well, what's your BTU? What kind of a motor do you have? What's your width? Things like that. I mean, that's all going to be critical information to us. The more information you can give us, the quicker, the easier and faster we can help you. If we got to keep going back and forth requesting information, it's just going to delay you on your job and taking care of your customers. So full model and serial numbers at all costs, please. Yeah, it's just the Bryant nomenclature. This is the common units that are out there right now, showing the 59 series, the 900 series, and then the PG series for the panes. Kind of tells you what's available in what series. I'll leave this up for a quick hot minute if any of you want to take a screenshot of it. Moving on. Just kind of some of the basics of these units. They got the quarter turn knobs on them still. Doors are gasketed. I know from experience being out in the field for so long, I mean, it's real easy if that gasket's dangling, hanging off, whatever, you just rip it, throw it, get it out of your way and move on. Don't do that unless you want a 3 o'clock in the morning call back for a noise complaint, and you're going to get there and it's just going to be because of that door gasket being gone. If you don't have the gasket, get some foam tape off your truck, make your own. Does the same exact thing. But leave it on there or repair it, replace it, whatever needs to be done. The doors don't change with orientation of the furnace, whether it be upflow, downflow, anything. The thing that does change is that nameplate on there. You can flip that so that you're not putting a downflow furnace in, making it look upside down to the customer. Swap your nameplate over so it looks proper and professional to your customer.
Hey, Ben.
Yes, sir.
Hey, can you go back one screen to the Bryant screen?
This screen?
I believe that's the one Cass was talking about.
Cass, is this the right screen you're looking for, bud? Or you want the Bryant nomenclature screen?
It says Bryant screen. Bryant screen. So maybe the nomenclature one? His answer was yes.
Yes, this is the right screen. Question mark. All right, hopefully you got that screen. Let me back up one more just in case that's the one you wanted real quick, Cass. All right, sounds good, Cass. Thank you. All right, moving on. Bam. Showing your sealed vestibule, all your knockouts. If any of you guys are installers, you're going to know about your knockouts, what and where to knock them out at. It's just kind of showing your different options that you have. All your pipe grommets are included in your loose parts bag, so pay attention to that. Save your spare stuff. Get like a little tackle box or something in your truck and save all your spare grommets. They come in handy every now and then. Oh, back up too quick. Heat exchangers. Again, this is not new information. It's new features to the 59 series. We're just touching base on them. They're more compact and we got rid of the eyelets. No more cracking rings. And then the secondary big thing there is they eliminated the U-bends out of them. So, and they are much easier to service now with the redesigned slide outs on them. So it's actually kind of a piece of cake to get those bad boys out now. So burner assembly, I just kind of touching base on your burner assembly. One thing I'll point out here, and it's going to repeat itself a couple times, is your igniter resistance. It's the same for all carrier furnaces, 40 to 70 ohms on your igniter at room temperature. So they don't take a long time to cool down once you shut down, but give it 3-4 minutes before you check it if it's been fired up or had flames running across it. Burners, they're one piece now, have been here for a few years. All getting together, we got rid of the misalignment option or problem, I should call it, with our snap togethers and our flame crossovers. That's a done deal. One thing with these is sometimes they do get warped. If you're having a flame problem, you're shooting high on your sides, on your outer burners, take that out and put it on the ground, on a level piece of ground, that is, and see if you got a warp in that. It's not a real common problem, but they do warp sometimes and get bowed, and that will throw you off, create all sorts of problems. So just a little hint there. Yeah, burners are getting together, eliminates your misalignments. Here it is again, 40 to 70 ohms at room temperature on your igniter, 4 to 6 microamps on your flame sensors. With that being said, don't just assume that a unit is firing up and shutting right back down 2, 3, 4 seconds later, you got a bad flame sensor. Make sure you physically check your flame sensor before you throw another one in there, because I've had it the last couple times in the last few weeks. Guys are, I got a bad flame sensor, and they put another one in, and still got the same problem. Now they're throwing a board in. So unless you want to eat the cost of parts to your customers, because we all know it's a correct thing to do to just throw parts in, charge your customer for whatever we put in there. So just save your customer and use some time and effort and just check it real quick. With that being said, too, if you don't have a meter that checks microamps, get one. Like Craig talked, having the proper tools for the proper jobs. Manifold assembly, it's pretty much the same manifold assembly across the board. One big thing here is if you have that thing apart, when you get your ground back in, make sure that that screw is tight and not stripped out, or you will have problems. On that ground has to be tight. And with that said too, I mean, if you're going out, reverse polarity issues or trip outs, things like that, just hit that screw real quick and make sure it's tight before you do any further, so that way you don't have that problem. Matthew Jorgensen, any issues with propane kits on these burner assemblies? No, as long as they're properly taken care of and serviced every year, so you can make sure you're scrubbing them, because they do soot up. You will get the propane soot up on them, especially if your gas pressure is off. And so make sure that they're taken care of. What about the screws, Matthew? Single stage gas valves. I mean, that's nothing new to any of us. So I'm just kind of showing the overview of the most current parts that we have out there. 2-stage gas valve, same thing. You just, now you got your high side, low side.
Can you guys hear me?
Yes. Who's speaking?
Oh, that was Cass.
What's up?
What's going on?
Not much. You're live on our conference, so.
Okay, I'll mute.
Matthew, I will touch base with you on your issue after this is over. Modulating gas valve. Make sure that when you're running your diagnostics on these systems, you know what's AC, what's DC voltage. That's another big thing we get a lot of the times is voltages are being checked incorrectly, AC versus DC. So make sure you know what you got going. This is talking PWM signals. Just kind of shows your plugs to where you're going on your pins. Yeah, I'll leave this up for just a second so everybody can take a picture of it if you want it. And this is for modulating gas only, by the way. Moving on. Single stage and two stage inducer assemblies. Again, nothing new. Kind of refresh to those that might not know or are newer into this. Your boot, your exhaust boot is 360 degrees. Can go in any orientation you want, up, right, left, down. Make sure that if you do adjust it, you retighten your strap or it's going to come off eventually with vibration. But the only thing on these that is a repairable part or replaceable part, I should say, is your capacitor. Doesn't go bad very often. But they do, and you can get just the capacitor for these. They're all ball bearing motors now. Really helps with burnout of the motors. You won't be changing inducers like you used to every 3-4 years. Again, adjustable vent couplings. Retighten your clamp. No external hoses required on this. All integrated into the motors now. And if you do have to replace one of these or fix a part on one, it's going to be a whole entire assembly you're going to get. No more part and amount. Which I'm sure none of you are upset to hear. So this is kind of a picture of the back plate or your collector. Your variable speeds with your ECM. Just kind of showing the setup of it. On these, your control box can be replaced. But anything else on here, full assembly going. And if you get a new inducer, it's coming with the control box. There's not a separate piece when the whole entire thing's ordered. Again, it's just going over the variable speed one, but all the same things. Ball bearing, adjustable collars, or coupling, excuse me. Your drains are integrated, and it's a full assembly minus the control. If you need just the control, you can do that. But if you buy the whole assembly, you're getting the control with it. Pressure switches, nothing new really has changed here. I will touch base just due to the fact I've had a couple different calls over the last few weeks with pressure switches on your, especially on your two-stage switches. Make sure your little drain hose is clear. Have a little tiny piece of thermostat wire. Don't jam it all the way in your switch, but use it to clear out your ports and make sure your hose is clear because that's been a big problem lately. Spiders love building stuff in there. One other thing, it's not the case every time, but if you're getting water buildup in your pressure switches, check your drain. Evaporator and furnace drains have to be separated. Your evap can pipe into your furnace drain, but it has to have an air gap in it. Had 2 calls this week alone on filled up pressure switches, and they both were piped straight together, creating a backflow problem. So it can be piped together with an air gap. So Keep that in mind. Also, for the newer techs, just getting into the heating side, your switches, your inducer has to provide at least time and a half time or more in order for your switches to close. So just keep that in mind. Have a little 1/4-inch T and an extra piece of vinyl hose with you so you can tap into your inducer line and check your pressure going to your switches so you can determine whether it's a switch problem or a motor problem or a clogged flue problem or clogged secondary, whatever your problem. Make sure you have the right tools to do the right jobs. If you call us, we're going to ask you what your pressure of your switches are. And if you don't have that T in that hose, you're not going to be able to tell us. So again, it's just a little 1/4-inch T, a little extra piece of vinyl, and a manometer. That's all you need. Blower assembly, nothing really crazy here. It is nice that they redesigned their slide out rails. It has made life a lot easier for most. That's about really the only big thing here. Your motors, kind of showing you. I'll leave this up for a second. Take a screenshot of it, take a picture of it, whatever you have. It's showing kind of what motors you're going to have and what models. Why you guys are taking pictures. If you're getting the 41 motor communication fault, can be your motor, can be your module, could be your board. But your module, when you have the ECMs that you can take your module off, pull that, take that module, pop it, get your Molex taken apart and look at it. Inside, you're going to find that resistor. It's about the size of a $1/2. It's black, about an 1/8 inch thick. Check that for discoloration, cracks, anything like that. Normally, if they crack, then they start creating a white film around that crack. Or if the whole thing just looks like charred white black, it's blowing. Replace that module. With that being said, check your motor. To do that, ohm out between on your motor side of that Molex plug, ohm out 1 and 2, 1 and 3, and 2 and 3. They should all be equal, not to exceed 20. If you're under 20, they're all equal. Spin that motor. It should spin freely. I state that spinning your motor with your module disconnected, because your module will actually create a magnetic force that will hold that motor from spinning 100% freely. So module disconnected, spin it, should spin free. If all that's said and done, it's your motor's 99% of the time good. It's in your module. Moving on. Your ICM flex motors, they're 1/2 horse and full horse motors. The module is replaceable on these. Here you have your ECM and PWM motors. You're going to have high voltage and low voltage going to these things. Your high voltage is supplied to them 100% of the time that you have high voltage supplied to your furnace. And your low voltage is depending on what your signal calls are. Your brown wire, it's going to be jumped between your two plugs. Brown is common, yellow is your power wire. You're going to have 0 to 15 volts supplied to that. Keep that in mind. Brown really does nothing except for your common. And then your readings on your voltmeter will change with motor speed. And you can dummy your motor, yellow and brown, put jumpers in there with a 9-volt battery, and that motor should run. Again, motor will use 120 on L1, L2, and then 12-volt power supplied. Down here, it'll show you on your ICM torsion motors what plug does what. 3 1s are 12, 3 2s are ground, 3 3 and 3 4 are your transmit and receive. Kind of talking boards here for a minute. Big thing is they've made the LED bigger and brighter for all of us blind guys to see. It's not real hard to see these anymore. It's not any of that turning your head at 35 degrees, just perfect. 45 degrees down just to see that LED. It's going to be right there in front of your face, pretty visible without even really hunting for it. You got adjustable cooling and heating airflows. And we are still 4-way multi-purpose 13 vent applications. They're smaller furnaces. They all use the silicone nitrate igniter unless somebody's changed it out afterwards. They have the safeguard switches on there. Don't just get on a furnace and safeguard switches trip, retrip it, fires off. You sit there for 15 minutes and it runs. Figure out why it tripped. It's 99% of the time be something in your flue. If you do get a bad one, you can test your temperature in front of it and see if you can find it tripping. It's got a little tiny slot in the side of that box that it's mounted on that your thermometer will fit right in. Make sure you're not touching the metal when you're testing it though. And then all models are still chimney friendly as long as your accessory kits are used. It's just kind of showing some of the updates. Like we just went over, and then just updates on the furnace cabinets and stuff. Installation basics, airflow, and your factory tabs. Pay attention to these charts on how they're showing to bend your tabs, especially with the end coils. This is critical. If you're bending downwards, if you look under upflow, second picture down, shows it being bent downwards 120 degree minimum. That is a minimum. Get it bent as much as you possibly can because you will get an air trap up in that little space there between there, and it can create problems. At all costs, bend them as far as you can get them. And no application does it allow those to stay flat. They're either up or bent all the way down in any application. Kind of just a picture on showing you how you can get in there with some folders and bend them. Downflow is critical that they just are cut out of there. Get them gone. This is next 3 slides showing you upflow, horizontal, downflow, what returns are accepted for what application orientation. Downflow, I'll go over here to horizontal because it's the most critical one. On your higher BTUs, you cannot use side returns. They have to come in the bottom. On your 60s and 80s. So keep that in mind. Read your installation manual. This is in there anytime. Your installation manual should be read every time you put a furnace in, but we all know that doesn't always happen. But when you're doing horizontal, especially, pay attention to this, please. Because if you do this and you do it improperly, you will be calling this because things are not going to be running right. And nothing's going to turkey off more than having to go back there and rework duct. So read it and do it right the first time, guys. Gas piping, we're allowed left and right side entrances on gas piping. No flex pipe connections inside the housing, cabinet housing. If you're flex piping, everything's done externally. Sediment traps are required. Left side, it's pretty simple. I mean, knock out straight in. Right side, easiest way to pipe in off the right side entrance on gas is get everything out of your way. Take your J box out, take your pressure switches out, get everything out of your way, get your gas line in there. There will, if as long as you do this right, there will be enough. I'm gonna leave this up for a minute so you guys can take a screenshot of it. Just showing your 2-inch nibble off your elbow. But take a picture of this so you have it. As long as you do it, I specify it here, there will be enough room to get your J box, your pressure switches, and everything mounted back up properly, no problems. So I'll leave this up for 1 second. Big things here, straight double off the gas valve with a 2-inch nipple on the backside of that into a tight 90. And then you're off and running back to the right. And when you're tightening in here, use a backup wrench on that gas valve. They didn't just put a pretty square there to just redesign things for their own good. They put it there for the purpose of you guys using it to have something to grab onto so you're not snapping gas valves. So use a backup on that when you're tightening in that 90. Showing once you're in, then you can get your J box and your pressure switches back in. If you look kind of almost dead center of this picture, you'll see that little box off that inducer 90 off that vent. That is that limit that I was just talking about, that safeguard limit. In case you guys were wondering what I was talking about, there it is. That will trip out if you have backdrafting issues, bad roof caps, clogged flues, things like that. Any trap of heat or backflowing is going to hit that limit and it will trip out for you. It is a manual reset. It is not automatic. So once it's tripped, you're coming out until it's fixed. So vent sizing, please pay attention to this in your manuals too. Things have got critical with vent sizing. Everything's a 2-inch takeoff, and then you're gonna go into 2.5, 3, 4, whatever be the case. But make sure that you are following your instructions and checking your piping charts before you start piping, because nothing will upset you more than the gas company come out and nail you, or you start getting pressure switch problems because our vents are wrong. So this kind of just a brief overlay of the sizing charts. With this being said, also pay attention to your altitude of where you're at. It doesn't need to be 100% specific to 145 Crown Road, Council Bluffs, Iowa. It's get at least your city and know about what your altitude is, because that's critical, and you'll see the differences as you look through these charts. So pay attention to that. Also know your differences of your 45s and your 90s as far as long radius, medium radius, and standard. Because you'll see the difference here. I mean, just a long radius and medium radius 90 is a 2-foot difference. So pay attention to that, and know what you're working with. Combustion air adapters, top of your, depending on how you're coming off the furnace, but they're basically your support for your pipes. So use them. Do not glue your pipe into this. If you do, you're going to be buying this and a whole bunch of pipe and a whole bunch of time. Let's push off to this next slide. You have your rubber coupling here to alleviate you from having to use glue. Make sure you use both bands when you do this. Next slide or two over, it'll show you the notches in your rubber pipe versus your notches down on your housing adapter. That rubber boot will slide right down over that with the notches. So make sure you pay attention to that. You don't just ramrod it on there. I mean, if you're lined up on your notches, it's going to go on pretty smooth. It's just showing you two different adapters. Right there's your notches. That coupling is only notched on one end of it, so it's pretty dummy proof. Just kind of showing your application for it. Another part of not gluing this in is every now and then, every now and then that rubber boot off your inducer motor is going to crack. It doesn't happen often, but it can happen. Or if you have to replace that inducer motor, it's not going with that new boot on there. So you're taking that off the old and putting on a new one. If everything's glued in up on top with that furnace, you're going to fight getting that inducer motor changed out. You're going to add about an hour to your service call, completely unnecessary. So use your rubber coupling and no glue. It's just showing you putting it in again. That's kind of just a dummy view of it, showing your incoming out of your furnace into that boot, and then your exhaust will come down into it. And it's saying torque it down at 15 pounds. Very few of us carry a torque wrench with us, but make sure your straps are tight is the bottom line of that. If you have a system that can use fresh air out of the structure and not have to be piped all the way outside, you are required to have at least a 12-inch standoff, however you're piping that in. Read your manuals, because not every system accepts this. Most of your modulatings, you have to go outside together, and you have to be in the same pressure zone. One pipe can't go out the right side of the house, one pipe go out the left side. They have to be in the same exact pressure zone, or you will have pressure switch problems. I'm kind of showing you how that boot comes off and you can reposition it. Outlet chokes. 40,000 BTUs. And you're under 2,000 feet of elevation. And your pipe's going to be short. You're going to put a choke in there. That choke comes in your loose parts bag. And it snaps right in. If you look at that bottom picture, you have your main outlet, and then internal is that second circle. You'll see those notches there. That choke has clips on it, and it'll clip right into those notches, and you're off and running. Again, when to use it is 10 foot or less at 2,000 elevation or less on a 40,000 BTU unit. Read your manuals when you're putting stuff in, and you'll know if you need that or not. If you have questions, call us. 80,000 venting. B vents required. I do not know of a single area of the United States anymore that B vents not required anymore. Single wall pipe transducers are not permitted. Twinning. This is kind of a going history right now. When we're talking our twins, we're talking identical twins, not fraternal. They have to look identical. BTU ratings, boards, everything has to be identical. If you do get a board, don't quote me on these numbers, but we'll use a 34 board and a 61 board. Say the old one's a 34 and it's superseded to a 61 board now. Replace that board in both units. If one goes bad, they're both bad. Replace them both, unless you can get identical boards, or you will end up with problems. Again, We're identical twins. We're not fraternal. Everything has to match. And there are no triplets in furnaces. Had that question asked lately. Can I tie 3 furnaces together? No, we're twins, not triplets. So only 2 at a time. And critical number 6, your high volt 115 volts must come from the same phase or leg in the panel. If they're off separate, you're going to get problems. Condensate traps and drain elbows. If you take a furnace out that's still got a good drain elbow on it, put it in your truck. Save it for later. You will use it. Those things dry rot, they crack, and that will be a 2 o'clock in the morning call for you that somebody woke up and they got a puddle of water on their floor. Save those elbows off of other furnaces if they're in good shape. We're on the clear traps now. We got rid of the opaque ones that you can't see through. The clear ones, they allow you to see all the grime guck buildup in them and lets you know that you're actually getting them cleared out and cleaned. These things are cheap. I would recommend getting 1 or 2 and just putting them on your truck, or having them somewhere readily available to you 24 hours a day if you're on call. Because if you get one that's cracked or completely clogged and won't clear out, you can just throw another one in. They're cheap. I mean, and for as cheap as they are, I mean, if it's completely full of crap, don't even try to clean it. Just tell your customer, hey, we're going to replace it. Get a new one in there. Kind of just a breakdown on how it's all put together. When you're putting your 90 on the outside, don't glue that in. It comes with a clamp for a reason. If you glue that in, anytime you have a problem, you're cutting that all apart and you're replacing it all. Clamp it in. Your exit of your 90 can be glued in, but where your rubber hose meets your 90, that's in your loose parts bag, use that clamp to hold it in place. Do not glue it in. Kind of just showing you how to put it in and where to clamp it. If you are going to drain out the left side, I'm going to jump ahead 1 slide here. You have your Z pipe. That is what's used to exit the left side of your furnace. Make sure that that's laid flat across your furnace and does not have an uprise to it coming off that 90. And if you have an uprise in it, you're going to get water trappage. Omar. So you don't need a T, a 90 will do just fine. Correct. You do not need a T coming off of these. It comes with that 90 that you can just, it's a straight 90. It's got a connection point for your hose. It just goes right on. It's kind of showing the layout of the Z pipe. And then it also comes with a coupling and extended piece for your wider furnaces. Anything basically 17 and above, you'll put that extension on there. Temporizes. This is critical. If you guys call us and you're having problems, we're going to ask your temporize. That and static pressure, and we'll touch on that in a minute. But those are kind of like your entry blood pressures into the emergency room. You don't ever get to go to the ER without them taking your blood pressure, your temperature, all that good jazz. Same thing with us. You don't get to talk to us until you take your blood pressure. AKA temporizes and static. When we're checking our return, we want to get down as low on that return and as close to that blower as possible. You don't want to grab a return up in the return trunk or clear up against the ceiling or something. Get down closer towards the bottom. When you're checking your supply, get away from your plenum and your takeoff. Get up and around the corner 3-4 feet and then grab a temperature there. And if you don't believe me, try it one day. If you've never done it, go right above your coil and then go over, and you're gonna probably have an 8 to 10 degrees difference. So get up and around the corner, and that's your supply. Your supply your supply minus your returns, your temporize. Here we'll look at it. 135 supply, 70 returns, 65 supply, or excuse me, 65 degrees difference. That's your temporize. Most of our stuff is rated either 40 and 70 or 50 and 80. 65 is pretty good. Now, say you're rated for a 50 to 80 and you're 79 degrees temporize. Don't say, oh, I'm below 80, I'm good to go. No, figure out your problem, because you're going to get above 80. So figure out where your problem is, whether it be airflow, dirtiness, whatever. Anytime you're checking temporizes and static, make sure everything's clean too. Coil's clean, filters clean, blowers clean. Make sure the system's clean before you start trying to diagnose it. We're bumping into fault codes here. If you get to a system and you don't have a current fault, you can remove any wire off the limit circuit, your red wires. Pull it off, put it right back on. Your code will come back and it'll flash 4 times. And then you're going to resume your normal heartbeat. If you're past 72 hours of your last fault, you will not be able to pull it back off. Most of our newer stuff is running off UI, so you're going to find your faults there. But if you don't have a UI, you can pull it off the board as long as you're there within 72 hours of its last event. Fault codes, they're pretty standard across the board. There's a few differences here and there. Big thing though, no fast first, slow, and which one comes first. Fast first, slow second. And that's critical, especially when you get into your double codes like 13s and 31s. Which one do we really have? And that's going to be a big difference. If we look here, 13's a limit lockout. We look here, 31's a pressure switch problem. So which one are you really traveling after? Don't chase your tail. Take an extra second, check it, triple check it, especially in the middle of the night when you just got woke up. Make sure you know what you're seeing. It's going to save yourself a lot of time. But our codes are pretty standard across the board. Every single furnace, your codes are going to be on your furnace door. If you don't understand, you need clarification, whatever, call us, shoot us an email, text message, whatever, and we'll get you as much information as we can on it. Now, 33, limit circuit fault. I bring this up because if none of you have experienced it yet, you're probably going to. On the new 4.05 software that just came out for our UIs, and I think it was in 3.94 also, but it was really pushed in on the 4.05. You will get to a call, and on your UI or your customer will call you and tell you, I have a fault 126. It's 126 fault code on my thermostat and it's saying a high heat cycle active. This is Carrier's way of not freaking a homeowner out that they have a limit trip going on. 126 means 33 on the furnace. Again, 126 on the UI, 33 on the furnace. Your furnace has been into limit trips. You have to have 2 consecutive limit trips for it to register the 126 on the thermostat. This was a big problem. The reason it came about, was due to overheating issues with zone systems. Last year, I guess it was a really, really hot year for Carrier in these issues. So they put something in their programming for it. If you get a system that is in limit trip and you are on a zone system, let me back that up. You do not have to have a zone system on this unit in order to have this malfunction in this fault code. It's any system with the UI, but it's honed in on zone systems. If you're on a zone system and it tripped out on zone 1, it's going to open that zone 100%. It's going to open the remainder zones 25%. And it's going to force that thing into high heat, and it's going to sweat your customer out. Carrier's way of doing it this way is they'd rather make you sweat than freeze. So they figured if they open the faulted zone out 100%, open everything else 25%, your customer's going to start sweating and wonder why. And then they're going to call and say, hey, my stuff's not working right. And you're going to get out there. Again, it's a new fault code. You will not find it in a manual anywhere. So if you find 126 on your thermostat, don't even go to a manual, because you're going to sit there and look forever. You will not find it. As of now, updated thermostats down the road, it might be there, but as of now, you will not find it in manuals. So yeah, it's 126, and it is referring to limit trips on your system. Right, there's that code 41 I talked about earlier on that motor blower fault. And it's basically telling you that your motor failed to reach its RPMs. So only a couple of models you're going to find that in, and that's the 59NM7 and the 987M, and then the 59TN6. But again, your furnace will have all these fault codes that are related to that specific furnace you're working on. Okay, so static pressure right here, blood pressure, just like at the doctor. We will take your blood pressure when you call us with anything pressure related, temperature related, anything. We're going to get your blood pressure, aka your static. Down at the bottom, are you really doing your job if you fail to measure static pressure every time you service a unit? Nope, you're not. Just because it was fine in the spring doesn't mean it's fine in the fall. Just because it was fine 3 years ago doesn't mean something didn't happen and things aren't fine now. Before you measure static, just like I said before, we measure temp rise, everything needs to be clean. I cannot stress that enough. I'll have guys and they'll be like, oh, I'm having high static on my supply. And so we look at everything and they can't find it. And then somebody else from their company goes out there the following day and there's a plastic bag laying across the coil or something. Check everything. I know that sometimes it's a pain to get in and check your coils, but do your customer the favor and make sure it's clean before you diagnose it. Establishing a proper airflow should always be the first diagnosis that a tech does, because nothing will work properly, nor can the system be charged properly until an adequate airflow and heat load passes through a clean evaporator and fins for absorption into the evaporating refrigerant. Again, clean is the key word. Now, a lot of the newer techs out there don't know about static pressure, let alone how to check static pressure, where to check static pressure, any of that. This picture from left to right, left is your return into your blower through your furnace. That middle blue area is a transition into your evaporator and then out to your supply. If you look at your return and that transition, you'll see where the black line's notched out a little bit. That is where static is checked. After the filter, before the blower, after the furnace, before the evaporator. I'm going to repeat that because you're going to see it here in about 10 minutes when you take your test. Well, actually, after Rob's done. Sorry, Rob, I forgot you're next. But again, after the filter, before the blower, after the furnace, before the evaporator is where static's taken. We may, during talks, have you pull pressures from other areas, but that is where we're starting. This shows you again from left to right. Left, return into the blower, through the furnace, through the transition, through the evaporator, and out your supply. Get your holes large enough for your testing equipment. Don't drill them super big holes. Big enough for your tubes, your pitot tubes, and you'll be good to go. Manometers, Magnehelic gauges. There's a lot of older techs out there still have these bad boys. They're probably the most accurate testing equipment that's ever been manufactured for the HVAC world. They're bulky, take up space, they're very fragile. But here, looking at return, you'll see where your air filter is. It's right above that box that says air filter. So we're between the filter and the blower is where we want to go. You'll see they have their tube just barely stuck right inside that ductwork. That's all it takes. No more than 1/8 of an inch through the side of the duct. Do not go more than that, or your numbers will be completely off-centered. Pay attention down here. We're going to talk about this here in a minute. Do not center an in coil on furnace without a transition. We'll talk about that here in a second. That's your return. Here's your supply. After your furnace, I know it looks like it's inside the furnace, which it actually is. Best thing to do, if you can access the back of the furnace, get in the center of the furnace, about 2 inches down from the top lip of that furnace, drill a hole, you're right there. If you have to do it from a side, do it from a side, but if we can get in the center, better. If we can't, it is what it is, but no more than about 1/8 of an inch inside there, unless you have pitot tubes, and we'll go over that in a second. But our return was 0.2. Our supply, we're at 0.4. 0.2, 0.4 equals 0.6. Here's your airflow chart. I'm going to show you, say we're on a 70-08 system. Our static was 0.6. We're running on high. We're running 845 CFM. We're 350 to 400 CFM per ton. Keep that in mind. If you do not have an airflow chart for a system when you get there, aka the instruction manual is not there, call us. We can send you something. You will need this. Pitot tips. Earlier, Craig was talking, have the right tools for the right job. Pitot tips are pretty much a necessity, especially for as critical as airflow's getting and static pressures and everything. Pitot tips are not going to lead you wrong. Just a long, that's not real long. It's 5 inches or so, kicks off to a 90. It's going to have a magnet on it. So you just stick it right into your ductwork. You don't have to sit there and hold it. It's going to have an arrow on it to show you which direction to have it for your airflow. They're great to have. Right there shows you your pitot tips in use. I know that with hoses, I said no more than 1/8 inch in unless you're using pitot tips. Once you have pitot tips, you can penetrate that cabinet. You get further down in there, but that's what those are designed for. A normal return is 1/4 to 1/3 of your entire ecstatic pressure. Your supply is 2/3 to 3/4 of your complete pressure. If you're backwards, you got big problems. Right there, when I said pay attention to that, do not center an in coil. In coils pretty much take transitions anymore. 4-inch minimum transition from furnace to bottom of the coil. There are a few exceptions here and there. Read your manuals on it of what is required, what is not. 80,000s are kind of on the borderline of whether you'll have problems. Anything above 80,000, if you have an in-coiled no transition, you're going to get your right side limit trip. They have increased, they have a redesigned limit for that right side that increased your trip or your trip temperature, but it's not a solve-all. I mean, don't just have an in coil sitting there on top of your furnace and say, "Oh, I tripped my right side. I'm gonna throw this higher limit in there and move on." You're gonna be back to have another limit trip problem. Need to have risers in there. Problem with that right side limit, if you look at these in coils, where your V is on the right side, your middle slab comes down, catches your right side slab and goes back up in that V. That right side limit sits pretty much, if that coil is centered on there, it sits pretty much directly above that limit, and it will come up. Your air hits the bottom of that V and creates a air block basically, and comes right back down on top of your limit and trips you out. So it's a heat trap. So I'm going to leave this screen up. Take a picture of it. Any questions? I'm watching the question and answer box and the chat box right now. If you got any questions, let them rip. Brian Feeney, hopefully I said that right. UI 126 high fire. Why? Like I explained it's a limit trip problem, and instead of having a limit trip and locking out a system and freezing out a house, they decided to reverse that and shove it into high fire to sweat you out to make you know there's a problem. They'd rather you wake up sweating than wake up freezing and all your water pipes and stuff broke. So they switched it over, put it into the high fire, because you're gonna know that there's a problem that way too. But they'd rather see you sweat than freeze. Does that answer your question? Matthew Jorgensen, can you email me at ben.point, P-O-I-N-T, at comfortproducts.com with your contact information, and I will call you in regards to your questions. Anybody else got questions? Otherwise, I know I went a little tad bit over. Take a quick little 10-minute break, hit the bathroom, smoke if you got them, get a drink, whatever. Rob will kick on here in just a minute. It's 5:08. He'll be on at 5:15, and then try to blast through and get you guys out of here at a decent time. So it's been my pleasure, guys. If you guys have any problems, my name again was Ben Point. Give us a shout. We'll take care of you. Rob, you there?
Yeah, I'm here.
Okay, 10-4.
What are you guys seeing? Hello?
Nothing yet.
Good evening, everybody. I'm Rob Roach. Thank you for attending the 2021 fall training. Today, we'll discuss the defrost controls and the KFCEH electric heaters. First, we'll cover the defrost controls. We will go over the operation of these four control boards, the HK32EA001 and the 007, and the sequence of operation, and the HK32EA003 and the 008 with the sequence of operation. Covering both the standard and the quiet shift defrost controls for single stage heat pumps. The control is designed to operate with a Y call to the compressor contact. The defrost timer accumulates the compressor runtime on a Y input signal. This control also requires a 24-volt signal to R and C terminals to power the control timer and the output functions. The reversing valve function is also routed through the control on O circuit. It was introduced in late 2001. It has a Molex plug instead of the old quick connects. There is no short cycle timer, so that's a compressor timer. And it replaces the old CESO 1300024 from production. Okay. The timer is configured to provide a 10-minute defrost cycle, and it's field selectable for a defrost intervals of 30, 60, and 90 minutes. The onboard relay switch, the reversing valve, the outdoor fan motor, and the auxiliary heat. The defrost termination is provided by a clicks-on disc thermostat. The timers are reset by the defrost termination and starts when the disc thermostat closes. Factory default setting is 60 minutes, though in a number of southern locations, 90-minute provides optimal overall performance in the heat mode. Shorter compressor run cycles may be needed when the unit is located close to body waters of ponds, lakes, and rivers. High humidity winter environments may require a 30-minute run setting. Northern locations with extended periods of below freezing temperatures may also require a 30-minute run cycle. Okay, the defrost thermostat opens at 65 degrees, plus or minus 5 degrees, and closes at 32 degrees, plus or minus 3 degrees. The thermostat interval timer starts when the defrost thermostat closes, and the defrost cycle is terminated when the defrost thermostat opens. So what we're kind of saying there is we kind of look up at the chart and we got the 30, it's 60. I know it got 90. We got 30, 60, and 90. When we have that particular one, it's letting you know that we're going to have compressor heating going on until the thermostat closes. When the thermostat closes, now the timer begins. On this particular one, we have 60, we have a 30-minute. So it's still going to run on compressor heat for 30 minutes. During that time, as long as the defrost timer, the defrost thermostat does not open, then it will initiate your defrost. Okay, so when the timer is the timer jumper is left off, and we're talking about the W1. Let me get a little. We talk about the W1 jumper, and now it's set on 30. If this was set on what was just left off, it's going to default to a 90-minute compressor run. Using the speed up terminals, by shunting across the two posts for the duration of that's on the speed chart, the normal operation of the control will be speeded up by 256 times. Because the defrost sensor is a simple switch, it opens at a design temperature set point and closes at a lower temperature set point. The temperature can be temporarily bypassed with a jumper for testing purposes. When jumpering out the defrost sensor, use an ohm meter to indicate whether the sensor is open or closed. Along with the ohm meter, use a coupling style K sensor mounted on the liquid line near the sensor to measure the make and break point of the contacts. In warmer weather, not above 65 degrees, you can disconnect the fan, the condenser fan motor to simulate a colder temperature. Different units designed to require different temperature activation and termination set points. For this reason, always consult your part selection program to assure the correct sensor is selected when replacing the sensor. For your defrost can last up to a maximum of 10 minutes, or when the defrost thermostat opens around 65 degrees. The outdoor fan relay is designed for a maximum amp current. The current of 5 amps at 240 volts. This is normally closed set of contacts, which opens when defrost is activated. So we're looking at the defrost board here. Here's the contacts that we're talking about for our fan. They're considered kind of K1 contacts. The outdoor fan's open, turning off the motor. When the defrost is activated also, your O output to the reversing valve is placed in cooling mode, with obviously the exception of the outdoor motor. And your W2 output energizes the supplemental heat. There must be a continuous 24 volts AC to terminals R and C. So the sequence of operation, the thermostat calls for heat through the Y circuit. The power is supplied by Y terminal through the Molex plug. The internal compressor timer begins accumulating time once the defrost thermostat is closed. The defrost thermostat closes once the outdoor coil reaches defrost sensor closing temperature. Internal clock accumulates the running time as long as the defrost sensor remains closed. When the accumulated compressor runtime equals the defrost set point, the control activates the reversing valve. It de-energizes the fan motor and provides 24 volt output to the W2 supplemental heat circuit. Control remains in defrost for a maximum of 10 minutes, or when the defrost thermostat opens. Once the defrost thermostat concludes, the outdoor fan is re-energized. Call on W2 circuit is eliminated at the control, and the reversing valve is de-energized. Okay, so why do we kind of, in our meetings, always go over sequence of operation? because it really helps us when we need to troubleshoot and walk through our circuit. So when we're in, with the thermostat in heat mode and the thermostat falls below the set point, sends a Y signal, and it goes through, comes out. If we have a low pressure switch, a discharge switch, high pressure switch, which most of ours are going to have a high pressure switch, and it's going to go up to our contactor coil, which unfortunately it looks like I got it cut off. And that's going to go ahead and start our unit. Now it's going to just keep running in compressor mode, and the thermostat's going to be satisfied, or it's going to continue to keep running. We're going to start building up some frost. And then we come over here, our defrost thermostat says, hey, I'm cold enough and we should start thinking about defrost. So now we can go check and see if, we're closed here for troubleshooting. We can go up and see if it sends a signal to our O. That's gonna go into our triac controls, which is our controlled time logic. And it's gonna go ahead and wait for the selected time. On this board that we have right now, we have it selected for 90 minutes. And as long as that defrost thermostat stays closed for 90 minutes, that's when it'll go into defrost, come back, energize the coil from the timer, and it's going to come over here from our R, and it's going to send two of the signals that we have. It's going to close this set of contacts, come back. There's your O. O is going to go hit your reversing valve. That's going to switch it into the cooling mode. So now we could take some of the hot 70, 72 degree air temperatures in the refrigerant, have that send out to the coil and thaw out. At the same time, we're going to close the other set of contacts, come back, go through our W2 terminal. That's going to go into our fan coil or to our furnace and bring on supplemental heat. So now we have sequence of operation that we understand. So if we already see that, hey, defrost is initiated, we heard it come over, and now we go in, we find out we don't have any resistant heat, or the gas furnace is not coming on, we can come back and check and see if this contact is open or closed. Same thing if a reversing valve does not make, we could see if we have 24 volts to it. If we do, then we can go ahead and isolate it, ohm it out, see if our coil is open. And that's kind of why you find out when we do most of our training that we really include a lot of the sequence of operation. Okay. We're going to the quiet shift board. This control is uniquely designed to provide a quiet shift feature during defrost on initiation and termination when the quiet shift feature is enabled. This feature comes from the factory disabled. So you can simply push the third switch located on the left side up. So here we are at our switch. This switch, the third switch, goes up. Even has shift right on it, right here, quiet shift. So that goes up. This control also includes a 5-minute anti-short cycling timer designed to initiate when a Y signal is interrupted. So anytime that if we start cutting out on Y, instead of being a short cycle and kind of damaging that compressor, we're going to wait 5 minutes, let things stabilize again, and we're going to start it back up. The short cycle timer can be deactivated by cutting the recycle timer relay resistor located on the right side, right here where it tells you, cut disabled, recycle delay right here, you will cut that. However, once you cut that feature, it cannot easily be replaced or repaired. So really know if you really don't want that in your cycle. Also noted, this control is not a direct replacement for the HK32001 that we talked prior. The wiring for each of the controls is different than the 003 and 008. They incorporate a T2 connection used for the 5-minute anti-short cycling feature. And the 001 does not have a T2 terminal or the feature of the anti-recycle. That was production in the deluxe units. Quiet shift and time guard was added. This one has a defrost time of 30, 60, 90, and 120. And it replaces the old CESO 110063-02. Here's a better look at our blocks. So how we set up our defrost interval time is if we want 30 minutes, we're going to be on and off. You can see on at the top, off at the bottom. So to be on, we'll drop this dip switch down. We drop this dip switch up. Second one would be down, would give us 30 minutes. If we want to be at 60, we'd go ahead and drop the first switch and raise the second switch and so on. Now over here where you got quiet shift, it comes from the factory and it's off, and we can just easily just click it on. Definitely a good feature and really helps with compressor noise level in and out of defrost. Excuse me. The pins marked speed up, short together, then released. It will defeat the 5-minute short cycle time. So that's going to be a quick little bump between these two speed up terminals. Same speed up terminals that we have again. We're going to go ahead and bump it, but we're going to hold for 5 seconds. The defrost thermostat's going to close or jumper. So after 5 seconds, you click it off, and that's going to go ahead and override that time. Okay, the quiet shift, when switch 3 is in the on position, the control turns off for 30 seconds. After the defrost and on defrost on the thermostat, again at termination. So what's going to happen here is, as soon as we have the compressor turns off for 30 seconds, now it switches over, hits your reversing valve into the cooling mode. 1 to 2 seconds after that, the compressor is going to start back up. By doing that, and it's doing that at initiation, and it's doing it at termination. And why it's doing it's to reduce the compressor scroll flank rattling associated with the reversing valve shift. Again, just targeting, kind of showing you the different positions of it. This feature does not address or mitigate improper airflow, improper system charge, installation where the outdoor unit is subject to excessive moisture and water from roof runoff, deck runoff, any other structure causing water to be directly towards the unit. A compressor that operates for some period of time with incorrect refrigerant or commissioned incorrectly may become noisy, where this feature cannot address that noise issue. Other features: if the thermostat is satisfied during the defrost and the defrost thermostat is closed, the compressor will hold the defrost until the next heating cycle. The unit will start in defrost and run for the remaining time has expired, or the defrost thermostat's open. Sequence of operation: thermostats. It's calling for heat operation on a Y circuit. Power is supplied through Y terminal and R terminal of the control. Internal compressor runtime clock begins. Accumulated runtime once the defrost thermostat is closed. Defrost thermostat closes once the outside temperature below drops below the set point. Internal clock accumulates the running time as long as the thermostat remains closed. When accumulated runtime equals what the selected on the control activates the reversing valve, de-energizes the outdoor fan motor, drops power to the T2 for 30 seconds. As long as dip switch 3 is on, control remains in defrost cycle for a maximum of 10 minutes, or when the defrost stat opens right around 65 degrees. Once the defrost cycle concludes, outdoor fan delay is delayed for re-energizing to reduce steam cloud. A call on W2 is eliminated at the control 15 seconds past termination. With the dip switch on, compressor is turned off 30 seconds at the conclusion of the defrost. Reversing valve is de-energized and the compressor will start back up. This is another wire diagram. It's going to be the same situation as far as going through the wire diagram. What I really wanted to let you know about is here's the T2 that we didn't have on our last wire diagram. And this is what's going to go ahead and control the compressor time delay. And this is also going to lock out for the 30 seconds at the activation and termination of the compressor. On the brand new units that we have with aluminum coils, this time as far as the off cycle of the compressor has been increased to 1 minute. This defrost board is no longer in production. It's still available in some of the small pack units. Does have a time card feature, but like I said, it's kind of obsolete in the ductless split system and replaces the old CESO 1300076 control. Quick disconnects. Oh, that's what I kind of wanted to show you. We kind of went away from the regular disconnects and being Molex plug a while back. So you kind of know the difference. Do we have any questions about defrost controls? All right, let's keep going. Go into electric heat. Okay, we got the KFCEH electric heaters. When installing or service any HVAC equipment, read and follow all safety warnings and practices. So when we're looking through their installation guides, there's a lot of warnings. We got dangers that identify the most serious hazards, and that could result in severe injury or death. The warning, there are significant hazards can result in personal injury and death. Cautions used to identify unsafe practices that can have minor injuries or product or property damage. Here are some of the selection options for the heaters that we have. So we kind of look over here and we see we got a 9 kW heater with an asterisk. And this one's letting us know that, hey, this one is field convertible to 3-phase. and we come over here and we'll talk about intelligent heat later on. And they're letting you know that these are the approved ones that will be able to give you intelligent heat. So if you're looking for that, you'll be targeting these. Here's some units to make sure that these are 3-phase only. So if you're in a single phase, you would stay away from them. And then we also have where they talk about field convertible from single or multiple circuit. And I'm trying to find where that one was. I used to know. Must not be on this page. Okay. A common mistake when choosing like a 15 or a 20 kW circuit breaker style heater for a single circuit application. You can see when we look at our spec information, when we have the breaker style and we look and see what our amp draw and what it is approved to be, there's nothing there. We come over here to a dual circuited and we're good to go with, with using it. So if we know that we're going to be using a 15K or 20K heater, we want to make sure that we use the fuse style of heater. And then it's also letting you know with the double asterisk that you'll need to use a single point wiring kit with it. Please use the heater package that is factory and UL listed approved for the application. Keep you out of trouble. Okay, the electric heaters require a minimum airflow. Note, fan coil units with or without electric heat requires a minimum airflow. So we're going to go look at a 2-ton fan coil unit, and we're going to pick 10 kW. They're letting you know that you're going to need 700 CFM. So you will go to your fan coil unit. You will check what your static pressure is going to be and make sure it can deliver the minimum CFM. So a little bit more is better than being right at the number. That way, if they close some ducts up, if they use a different style of filter or the filter gets plugged, we still have some wiggle room. Okay, notes that they kind of talk about on the heaters. It says 20 through 20 kW, the larger heaters, you have to have a 1-inch clearance for the first 36 inches of ductwork. Then there's also a notice right here, kind of give you some caution and tells you what's going on is notice that the caution to move the wiring pigtail to prevent possible damage. So they're letting you know of that. And then over here, I did not highlight it, but remember to remove the adapter when using the larger I think it's 28 to 30 kW heaters. So you'll go ahead and remove the first little panel when you're adding your heater in it. On the larger ones, you remove this adapter as well. Okay. Fan coil units of 3.5 ton or larger, remove the wire tie to lengthen out your wire loom. The wire harness over here is kind of letting you know that it contains high voltage and low voltage. If the thermostat is located more than 100 foot away from the unit, use number 16 gauge color-coded insulated wire. And down here, it's giving you a reminder that, I get the thing to work, there we go. That your transformer for 208 applications, disconnect the black wire from the 230 and reconnect it to the 208 terminal. Electric heat control changes. Current heaters are now energized with DC relays instead of sequencers. This took place in July of 1998, so it's been a while. The main reason for this change is a quick response relay to the electric heat demand. Relays close immediately on a call and don't require a warm-up time like the sequencers did. This eliminates cold blow experience at the beginning of the defrost cycle. Heat staging. If electric heat staging is required, a multi-stage heating thermostat is required. Consult your equipment supplier for a suitable thermostat. On our 3, 5, and 8 and 10 kW heaters, those are for single stage only. 9 and 15 heaters are adaptable for 2-stage operation, and the 18, 20, 24, and 30 heaters are adaptable for 3-stage operation. Rectifiers and time delay boards. A rectifier control board plugs onto the T92 style 22 to 24 volts DC heater relay at the QC1 and the QC2. A 24 volt input signal received at W1 terminal, which will be your terminals TP1, TP2, is rectified by a bridge rectifier. The voltage is applied to the output terminals at QC1 and QC2 to activate the DC coil of the relay. Auxiliary terminals QCA1, 22 volts DC to 24 volts DC, and the AC, the QC2A, it's going to be 22 to 24 volts DC negative, are in parallel with the QC1 and the QC2 to allow for additional DC relays to be controlled. Each heating element is controlled by a relay mounted on the heater panel. The relay has 24 volts DC. Each relay has a small rectifier attached directly to the relay coil terminals. The rectifier board converts incoming 24 volts AC W1 controlled signal and converts to a 24 volt DC. Some of the heaters may have up to 3 relays. The second and third relay rectifier also have time delay features and a small jumper built into it. The first stage relay has a minimum time delay. We're talking 1 to 2 seconds. The second and third relay boards have time delay features and a small jumper built into it. When the jumper is uncut, the time delay allows the second stage to energize in approximately 5 seconds after the first stage. On 18, 20, and 30K heaters, the third stage relay board jumper is cut at the factory, and that provides an 8-second time delay from the first stage relay closing. So your second stage has a 5-second time delay. Third stage has an 8-second time delay. If you have a heater with only one heater, the board is simply a rectifier that converts AC to DC. Boom, that's all it does. And then it sends a signal to the relay. If you have one more than one heater, one relay and heater is present, the second relay has a larger circuit board on it. This larger circuit board also rectifies the voltage, but has a 5-second time delay into it. And there is a small jumper wire on the side of the board. This board may or may not be cut at the factory. Cutting it simply adds another 3 seconds to the time function of the board. This way we have one board that performs two functions. The staggered time delay will not allow all the heaters to energize at the same time. So if we had 5, plus we go over here and we cut it, now we just made that 8-second board. Okay. So what I saying about the last 5 slides is kind of picture paints 1,000 words. So we come in here with our 24 volts AC and we go into our W1. That gets converted by our AC1 and AC2. So when we get to this point, we're looking for 22 to 24 volts DC. If we're going to go ahead and have another sequencer, another relay come on, we can go take these and send the power over to control that. Okay, the bigger board that goes on the second stage and also works for 3-stage, you notice there, letting you know that's the W1. So that's your W2, and that's going to be your 24 volts AC, converts to DC right here. If we want to jump or another board, we're going to go off here with the positive and our negative. And then we talked about the jumper. You can see that there's a little notch over here. It's going to be a lot easier to cut. And you cut this to get an extra 3 seconds to make it a total of 8 seconds. Uncut, this board is 5 seconds. Sequence of operation on the KFCEH heaters with a non-variable speed fan coil. Thermostat calls for electric heat, W signal, 24 volt, goes directly to the relay, which closes with little or no time delay, less than 2 seconds. Power of the fan is provided through the closing of relay number 1, or on the new FB4s with like the X13 motors, ECM motors, there's a direct signal to the blower motor. All heaters are energized with no change of motor speed. Heater remains energized until the thermostat removes the W signal. Once the W signal is removed, relays open, heat is de-energized, the motor shuts off with no time delay. A 90-second blower delay can be achieved by utilizing the G on the G with W function on our corporate stats. So you got thermostat, you will be able to get that. Now, if the heat pump is in the system, a 90-second off delay will occur because Y and G will be removed along with W, and this can be overridden by clipping the jumper on the circuit board. KFC heaters and variable speed application. Call from the thermostat W, 24 volt, goes on the W terminal on the circuit board and is fed to the heater relay. Blower is given a low voltage signal from the circuit board. There is no time delay. Call for electric heat regardless of the time selected on the easy board. The selections are for heat pump operation. If the heat pump is in the system, the blower will ramp up to the heating speed. The heaters remain energized until W removed from the circuit board. The heat call is satisfied when W is removed. Heaters will de-energize. The motor will go through 2-minute off delay regardless of the time selected on the easy board. If a heat pump is in the system and the Y is calling, the motor will ramp down to the heat speed. So what that's saying is if there's still a call and it no longer needs resistant heat, it will go down to the heat pump style of speed instead of the electric heat. If heat is satisfied at the heat pump only, the motor will go through and the delay chosen on the easy board. Changes in electric heat controls and staging. In the past, heat pumps combined with fan coils and electric heat system have been evolving in an effort to improve comfort of heat pump customers. This has resulted into several changes to the indoor portion of the system. The purpose is to bring everyone up to date on product changes due to the new comfort systems and to explain the difference between the newer operations. Different electric heat concepts have been introduced through the years with comfort as their goal. The first was the smart heat. Unfortunately, there has been some confusion with this product because the same name was given to two different controls. We have the smart heater package and we have the smart heat for the FKs and the FV fan coils are actually two different operations and they're not interchangeable. To eliminate the confusion, smart heat for the KF and the KV is now referred to as intelligent heat. Okay. Smart heater package had its own separate model number. This is a non-standard heater with a circuit board that is specific to it. Smart heat is capable with FA4s, FB4s, FC4s, FX4. So we're looking at some older units. It's not compatible with units containing variable speed. Outdoor thermostats can be used with it, and these are obsolete now. Just let you know what's out there, so when you hear the word smart heat, you know what it is. When using the smart heaters, staging of the heaters is controlled by the circuit board within the smart heater package, which any heat pump thermostat can be used. During normal operation, staging of the heater is a function of the previous heat call and the amount of time for the thermostat has an auxiliary heat demand. The heater will stage up one bank every 10 minutes until the auxiliary heat demand is satisfied. Then it will stage down one bank every 8 minutes until the primary demand is satisfied. During recovery from setback, the first and second stage will energize initially, and then the heater will stage up and down as in normal operation. When emergency heat is called for, two banks will be brought on initially, and it will be staged up by one bank of heat every 5 minutes until satisfied. Sorry, I had a computer malfunction. Intelligent heat staging. The KF and the FK and the FV fan coil units are capable of intelligent heat staging. When installed with a capable electric heater. And that's what was kind of shown on that table 1 that we were talking earlier. And a corporate thermostat, which is like the TP or the T6, and to be the NRH or the PRH, or a comfort zone 2 or zone perfect plus zoning kit. An FE fan coil plus the Infinity Evolution Control combination is capable of intelligent heat staging. Consult the fan coil installation and startup instructions for wiring details. Do not install an outdoor thermostat when installing for intelligent heat staging. Intelligent heat staging. To perform intelligent heat staging, proper setup options must be selected on the thermostat. The heat is staged and managed entirely by the indoor control board, or the indoor control, your thermostat. The thermostat or the zoning system provides 3-stage as required by indoor conditions. There's a 15-minute staging timer built into the algorithms, but this will be overridden by a 5-degree demand. So if you set it up 5 degrees higher, you can override that 15 minutes. The indoor control will not automatically stage up after the staging timer has elapsed, as did with the smart heat. If it detects improvement towards the set point, it will hold off to the next stage of electric heat. The goal of the intelligent heat staging control is to energize as little auxiliary heat as possible while maintaining comfort and keeping a more steady leaving air temperature. Okay, this is one of the, again, we're going to do a quick review of the wire diagram. If you notice the new dual limit switch, it's kind of marked here with a DD. The new limit switch has a redundant switch to open the circuit for extra safety on the new B series style heaters. This will be on the 15 kW and under. So here's a good little look at it. We got a temperature switch, limit switch here. Usually have one open switch. If this would get stuck closed, we have another one that can open. So we got redundancy on our switch. We talked a little bit going in the sequence of operation where we have our incoming volts, where we go into our rectifier. So we have our 24 volt hot here, our 24 volt common here. This is getting converted to DC. Then it will energize and go to 22 to 24 volts DC and energize that coil. We will come over and we'll start off with heat number 1. That will go ahead and energize, close relay number 1, your 4 and 2 and your 6 and 8, and bring that bank on. We can come over, these two are tied together. So if we had two-stage heat, we'd go ahead and energize this. With 24 volts, it would get converted to the DC, 24 volts DC, and then it would come over here and power your third relay, which would close your first and second one. This would happen right away. This would happen 5 seconds afterwards, and this would happen 8 seconds after that. Okay, here's kind of a main wiring diagram of your blower, your fan, and your heater package. Notice there's no Y connection on the fan terminal strip. The Y is wired directly to the outdoor unit. So it goes into the fan coil unit, you wire nut it, and you send it outside to your heat pump or your air conditioner. So when we come over here, We already kind of talked about walking through and doing the heat. We come over here and here is your motor contacts, terminals. So they have on high heat. For the heat, it's on white, goes up, and it is picking up right here at your Y connection. When there's a call for Y, it's energizing the power to it. On your line voltage side, your first C that you have, that is low voltage common, and that will go ahead and tie in and start up your motor. Thank you for the time today. And do you have any questions? Okay. With that being said, I am going to, this is the link for the test. So you can kind of click on that, download that information, and go ahead and take your test.
All right, everybody, thank you. Sorry we ran a little bit long today.